Hey guys, Charles here. Let's do AP Macro 2024 FRQ number 2. The table provided shows the quantity and price of food and clothing, the only two goods produced and consumed in the country of Maltros in year 1, year 2. Assume that year 1 is the base year. So our year 1 is our base year. We're looking for nominal GDP for year 2, but let's do year 1 first and recognize that there's a certain way I do these like a child every time. Our base year is year 1. I'm going to find nominal, I'm going to find real, and I'm going to find the CPI. Now, nominal and real are always the same in the base year, and you should just know that nominal is price times quantity. So price times quantity is 10 times 12, 5 times 16. That looks like 120, which is obviously 10 times 12. And 5 times 16, well, 10 times 16 would be 160. That doesn't help me. Let's go back. Let's just use a calculator. My brain doesn't work so well. 5 times 16, 80. Well, that's embarrassing. 160, half of 160 would be 80. Goodness gracious, Charles. 200, easy enough. Nominal GDP is 200. Real's got to be 200 then, because nominal and real is always the same in the base year, and therefore our CPI is 100. We know all of that right off the top of our heads. Well, after we calculate this, we're all golden for understanding how to get that. Again, your formula for CPI is nominal over real times 100 equals the CPI. So 200 over 200 is 1 times 100 would be 100. Easy enough. That's fairly simple. Let's find nominal GDP for year 2. That's what we're trying to find here. So our nominal GDP for year 2 is 13 times 10, that's 130, and 4 times 8, which is 24680 again. And 130, that looks like 210. So 210 is our nominal. The way we find real is prices, base year prices, times quantity of whatever year you're talking about, current year, which is year 2. So and let's get rid of these so we know what we're looking at here. It is quantity in year 2 times base year prices. This is a formula you just got to know. Lots of questions are asking this very same thing, and the College Board doesn't give you a formula sheet, so you just kind of have to know this. This is how we find our real GDP if we have this kind of structure. Question. 10 times 10 is 100. 5 times 20 is 100. Got to be 200 is our real GDP. Cool. Easy enough. Now, to find the CPI, we have our formula up here, nominal over real times 100. So that looks like 210 over 200 times 100. Should we do our calculator again? Might as well, right? 210 divided by 200. 1.5 times 100. So we just know that this is going to be 105. Easy enough. We went from 100 to 105. Inflation was 5% from one year to the next. Calculate the GDP deflator. Show your work. So we've already found it. We know our GDP deflator is 105, right? CPI, deflator, price index, all mathematically, all treated the same way. So we should just know that. They could have used the word deflator here or CPI or price index, and it would have been the same thing. So GDP deflator, well, we've already done our math, so it's right here. That is our deflator right there. Nominal over real times 100 is CPI, is the deflator, is the C, is a price index. Easy enough. What was the numerical value of the inflation rate from one year? Now, inflation rate, that is what we call a rate of change formula. We've already done it up there because it's easy to see for these numbers. But that rate of change formula is new minus old over old times 100. So the new was 105, the old was 100, divided by old, divided by 100 times 100, which is going to give us 5%. Easy enough if we do the math. Cool. I think we're good. 5% was our answer there. No, you could have just seen that and known it. They didn't even ask you to do that. It was easy to calculate. All right. Assuming that the expected inflation rate from year 1 and year 2 was 3%, and each of the following were each of the following better off, worse off, or unaffected as a result of the economic conditions. So let's think about this for just a second. There was an expected inflation rate of 3, but inflation was higher. Inflation was actually, again, 5%. So people living on a fixed income, obviously with inflation, people on a fixed income would have been worse off, right? Because their money has less value. It can buy less stuff. As price levels go up, what you and I should know is purchasing power, what you can actually buy, the real value of your cash is going to go down, right? You can buy less stuff as things are more expensive. Therefore, people living on fixed incomes are worse off. I think that's easy enough. Now, this one's a little more complicated, but not too much. Borrowers with fixed interest rates of loan. Let's play a game here because I like to explain this in a way that's a little more complicated, but easier to understand. And I haven't done it since last year or before the summer. So let's see if we can make sense of this. Banks expect inflation to be 3%. They're going to charge 3% for a loan. That would be the nominal interest rate that they would charge is 3%. Now, if inflation was actually, remember, our formula is nominal minus inflation equals real. This works for wages, interest rates, it works for GDP. This formula is stupidly important. I'm going to get rid of the interest rate here. We don't really need it. Nominal minus inflation equals real. If bankers charge you 3% and inflation is 3% also, then bankers would have not made any money. They would have not lost any money either, right? So if they charge you 3% and the price of everything goes up by 3%, well, they made 3% on the money they loaned you, but then the price of everything went up. They're no better off. They're no worse off. They're at 0 is their real interest rate, right? That's what they made on their money, nothing. They didn't lose anything either. But if they charged you 3% and inflation went up to 5%, and when they charge you 3% on a loan, now the real interest rate that they're going to make is a -2. Bankers would be worse off with inflation, or what we call unexpected inflation, right? So if it's a fixed interest rate of loans, the way we say this is that bankers, lenders, creditors, all these different ways that they like to say this just to be tricky, these guys lose. But at the same time, we would say that borrowers on the other side would win. And they win because they borrowed the money when interest rates were low. And now they're paying. The way we want to say this to explain that clearly is we say borrowers are paying back dollars that have less purchasing power. Now, you could also say also have less real value. The dollars that are paid back have less purchasing power or less real value from when they borrowed, right? When they borrowed, they could take $1,000 and they could buy $1,000 worth of stuff. But now the price of everything has gone up by 5%. So if you pay back that money to the banker, he can't buy the same amount of stuff that you bought when you borrowed that money because of the price level increase. So bankers are worse off when there's what we call unexpected inflation. This is your kind of understanding. We would say borrowers with a fixed interest rate are better off. They win. And they're better off because they're paying the money back to the bank that has less purchasing power or less real value. Hope that makes sense to you. There's a number of multiple choice questions like this, and we see them every so often on CPI, GDP questions about this who wins, who loses kind of scenario when it comes to inflation. Got to have it in your head, got to explain it to yourself a few times, and it starts making real sense. And then have to know what the College Board, it helps to know what they're looking for in an answer. Cool. All right. I think we're good on this one. Be safe. Take care.